Hello students, welcome back. So this is our lecture number 8 of the chapter Carbon and its compounds. So guys, here our first topic is about combustion reaction. But before that, if you have not yet downloaded our app Nakhyatra, then you can download it from the link given in the description box. There you can do the live classes, watch the recorded classes, and even to clear all your small doubts, you can also interact with me directly. Now see the chemical properties of carbon compounds. So what is the definition for combustion? Most carbon compounds also release a large amount of heat and light on burning. So any substance that burns in presence of oxygen releases heat and light on a process. So that is called combustion. So here one reaction is given where methane is burned in presence of oxygen. It releases carbon dioxide plus water plus heat and light. Now balance the reaction. And another reaction is also given where ethanol is burnt in presence of oxygen, also releases carbon dioxide plus water plus heat and light. Now balance it. Alright, now see this flame, it is an oxidizing flame. That means saturated hydrocarbon. And this flame is reducing flame. It is unsaturated hydrocarbon. Now can you differentiate between the oxidizing flame and the reducing flame by saying it? Yes, the oxidizing flame is blue in color and reducing flame is yellow in color. Okay, now see combustion. So what happens in combustion? Now in a spatula we took some sample of saturated hydrocarbon. Then we burnt the sample in the flame and we can see that there is blue flame. Then we took another sample of unsaturated hydrocarbon and then we burned the compound in the flame. Then we can see that it has yellow flame. Alright, now see the difference between saturated and unsaturated hydrocarbons. So saturated hydrocarbons are complete combustion and the unsaturated hydrocarbons are incomplete combustion. So in the previous combustion we saw that the saturated hydrocarbons has blue flame and the unsaturated hydrocarbon has yellow flame. And the blue flame is a clean flame, but there is black smoke in case of unsaturated hydrocarbons. So in case of unsaturated hydrocarbons, there is no sooty deposit. As you can see, there is no deposition of any materials. But in case of unsaturated hydrocarbons, there is sooty deposit, some ash-like stuff. Okay, so this is your kitchen burner. So it is your blue flame, which is clean flame and there is no sooty deposit. But this unsaturated hydrocarbons, we can see this while burning woods and all. So it has yellow flame and there is also black smoke. Also you can see some sooty deposit. Now the reason for incomplete combustion. So you can see here this saturated hydrocarbon has air hole open, and in case of unsaturated hydrocarbon the air hole is closed. So we will find that with fully open air hole, the gas in the burner burns with the blue flame or non-sooty flame. So this is the reason why the burner burns with the blue flame or non-sooty flame, because with fully open air hole, the gas in the burner burns with blue flame. Alright, now see for unsaturated hydrocarbon, as we go on reducing the amount of air going into burner, the gas in burner starts burning with a sooty flame. So if we reduce the amount of air going into the burner, the gas in the burner starts burning with a sooty flame and it has yellow flame. Now you might be thinking that the bottom of cooking vessels gets blackened. So it's why. So this is your brand new vessel. Now after using it for months, you can see that it turned out to be like this, blackish. So what is the reason? So this is the reason. See, the unburnt carbon particles get stuck to the bottom of cooking vessels, resulting in the blackening of bottom of vessels. So in combustion there is some unburnt carbon particles, so they get stuck to the bottom of cooking vessels, which results in the blackening of bottom of vessels. Okay guys, so are you clear up to this much? Okay. Next we will study reasons for flame and formation of coal. Why do substances burn with or without a flame? Have you ever observed either a coal or a wood fire? So this is wood fire and this is coal. Wood and coal just glows red and gives out heat without a flame. So this is because a flame is only produced when gaseous substances burn. When wood or coal is ignited, the volatile substances present vaporize and burn with flame in the beginning. So when wood or coal is burned, the volatile substances that present in them, they vaporize and burn with flame in the beginning. Alright, now next see the formation of coal. Coal was formed from the remains of plants that grew in warm humid swamps 300 to 400 million years ago. So here humid swamps means the wet areas, wetlands you can say. So trees and other plants that grew in swampy areas 300 to 400 million years ago died. So their remains got buried in the swampy soil. See the image here. The remains of the dead plants and other things that got buried in the swampy soil. Over time, these remains were covered with layers of sediments like mud and sand. So as time passes, these remains were covered with layers of sediments like mud and sand. In low oxygen conditions, the buried plant material formed a dark brown material called peat. So where there is a low oxygen condition, the buried plant material, they form a dark brown material and that is called peat. See the image here. Okay, so gradually more and more sediments got deposited over peat. Peat was compressed between layers of sediments and formed lignite. So here see, as gradually more and more sediments got deposited over the peat, so peat was compressed between layers of sediments and they form lignite. So lignite is a brown coal, which is soft combustible sedimentary rock that formed naturally. Okay, so further compression resulted in the formation of bituminous coal. So you can see the bituminous coal, it looks like some of these black substances. So further compression resulted in the formation of anthracite. Here anthracite is a very hard type of coal that burns slowly without producing a lot of smoke or flame. So this is anthracite. Clear everyone? Okay. Well, this is our last topic for today's lecture, addition reaction and substitution reaction. Reasons for addition and substitution reaction. So we will see for saturated hydrocarbon and unsaturated hydrocarbon. See, this is the structure for ethane, and when ethane is treated with 2 chlorine atoms, then it will form monochloroethane plus hydrochloric acid. Alright, now next see for unsaturated hydrocarbon. So this is the structure for ethene, and when ethene is treated with the 2 chlorine atoms, then the 2 chlorine atoms they get bonded with the 2 carbon atoms and they form dichloroethane. Next structure is ethyne. So again, when ethyne is treated with the 2 chlorine atoms, then they get bonded with the 2 carbon atoms and they form dichloroethane. So in case of saturated hydrocarbon, they undergo substitution reactions. They contain single bonds which are stable. So simply the substitution reactions means the reaction that involves the replacement of an atom by another atom. Now see, in case of unsaturated hydrocarbons, they undergo addition reactions. They contain double or triple bonds which are weaker and easier to break. So addition reactions means it is the combination of 2 or more atoms. Is that clear everyone? Alright, addition reaction. So see, this is a reaction given. Now by using the addition reaction, it is possible to convert unsaturated hydrocarbon to saturated hydrocarbon. Here, the unsaturated hydrocarbon undergoes an addition reaction with hydrogen by using nickel as catalyst to produce saturated hydrocarbons, right? Alright, so catalyst here we will take nickel. So this is the structure for ethyne. Now when ethyne is converted to ethene by using the nickel catalyst, again this ethene is converted to ethane by nickel catalyst. Clear everyone? Alright, so the addition of hydrogen to an unsaturated hydrocarbon to obtain a saturated hydrocarbon is called hydrogenation. So write down the definition for hydrogenation. Where there is addition of hydrogen to an unsaturated hydrocarbon to obtain a saturated hydrocarbon, it is called hydrogenation. Is that clear everyone? This is also an example given here, so all of you note it down. Alright, next see, the process of hydrogenation has an important industrial application. It is used to prepare vegetable ghee from a vegetable oils. So these are vegetable oil or unsaturated fat you can say, that is in liquid state. Now again they are converted to vegetable ghee which is saturated fat and in solid state by using the nickel catalyst. Okay, next is the substitution reaction. Saturated hydrocarbons undergo substitution reaction in presence of sunlight. So this is one reaction given when methane is treated with chlorine in presence of sunlight to give the methyl chloride plus hydrochloric acid. The replacement of hydrogen atom with a halogen in an organic compound is called halogenation. So halogenation means there is a replacement of hydrogen atom with a halogen in an organic compound. Alright, now next see the reaction with halogens. So this is methane, and when methane is treated with chlorine, then this chlorine substitutes one hydrogen atom from CH4. So it will give methyl chloride plus hydrochloric acid. Then again this methyl chloride is treated with the chlorine, and again the chlorine substitutes one hydrogen atom from CH3Cl to give dichloromethane plus hydrochloric acid. Then again this dichloromethane is treated with the chlorine, and the chlorine substitutes one more hydrogen atom from CH2Cl2, which gives the trichloromethane plus HCl, that is hydrochloric acid. Then again this trichloromethane is treated with the chlorine atom. Then again this chlorine substitutes one hydrogen atom from CH3Cl, which gives tetrachloromethane or carbon tetrachloride plus hydrochloric acid. Alright students, so we are done for today. Thank you.